Hello everyone, welcome to our Data Engineering and Visualization Lab series. I am Dr. Snehalatha, and in today's practical we will learn one of the most fundamental concepts in data engineering, that is data ingestion. Every data engineering project begins with collecting data from various sources. Before we analyze data or build dashboards or apply machine learning algorithms, we must first gather and organize that data efficiently. In this practical, we will build a simple data pipeline using Python and Pandas that reads multiple CSV files and merges them into a single dataset that stores the output as new CSV file. And by the end of this session, you will understand both the theoretical concept of data ingestion and its practical implementation. Let's first understand what data ingestion actually means. Data ingestion is the process of collecting data from one or more sources and importing it into a storage system where it can be processed and analyzed. These data sources can include CSV files, databases, different APIs, IoT devices, and many more things like cloud storage, social media platforms. In real-world organization, data comes from many various different systems, and if we see, a data engineer is responsible for collecting this data and making it available for further processing. For example, suppose a university stores student information department-wise, right? The computer science department maintains one CSV file. The IT department maintains another CSV file, and some another department like AI maintains third file. Instead of analyzing these files separately, we can merge them into a single data set, right? The entire process is called data ingestion. Merging of these files, that is called data ingestion. If we see, there are two types of data ingestion. The first is batch data ingestion. Here data is collected at scheduled intervals. For example, daily attendance, monthly salary reports, weekly sales reports. And second type, that is real-time data ingestion. Here data is continuously collected as soon as it is generated. For example, bank transaction, live weather information, and stock market prices. For this practical, we will implement batch data ingestion using CSV files. Move to data pipeline. Let's understand the complete data pipeline process. Our pipeline consists of 6 major steps. The very first step is reading all CSV files. In the second step, you are going to validate the data. This validation includes checking missing values, duplicate records, incorrect column names, empty files, like this. If any invalid data type is there, so we will be checking all these things. Next step, that is third step, in which we are going to merge all data sets, and in step 4 we are going to store that merged data set. Step 5 is use the data for analytics. This is actually the first stage of ETL pipeline. ETL stands for extract, transform, and load. So today's practical mainly focuses on the extract phase. Before we start writing a code, we need to get our environment ready. So now we will see which softwares we require for implementing this practical. First, we need Python. So any version you can install. This is the core language we are writing everything in. Every part of our pipeline, reading files, validating data, merging, storing, is going to be a Python code. So this is non-negotiable. If you don't have it yet, so you need to get it. Any version you can install. Next thing that is required is Pandas Library. So this is tool that does the heavy lifting. It gives us functions like read CSV, concat, to CSV, that let us read, merge, and write our data with just a few lines of code. So you can install it with one command, pip, that is pip install pandas. Next thing that you need, editor. So you can go with Jupyter Notebook or VS Code for actually writing and running your code. So you can go with these two options. If you go with Jupyter Notebook, usually installed through Anaconda, is great if you want an interactive environment where you can run your pipeline step by step and see your data frames as you go. Perfect for testing and learning. Or else you can go with VS Code. It is lightweight, powerful editor for writing and debugging your Python files. Either one works. Pick whichever is suitable for you. Next thing we need, that pip and operating system. So you will also need this pip Python built-in package manager. It's what installs pandas and any other dependency your pipeline needs. So these are the things that we require for implementing this practical. Alright, now let's get into actual code. We are going to use the Pandas library. If you have done any data work in Python, you already know this, the go-to tool. So here are some functions that we will use. Read CSV. It reads CSV file into a data frame. Concat, that merges multiple data frames together. Next is to CSV. It writes a data frame back out to CSV file. Head and tail, it previews the first or last few records. Shape, that tells you row and column count. Info or describe will give you structure and statistical summary of your data. So this is your basic code that we will write for implementing this assignment. Here what's happening in this code we will see one by one. First, we import pandas and the built-in globe module. Globe is what lets us grab every file matching a pattern in this every csv.csv file inside our data folder. Next, we loop through each of those files, read them into a data frame using read CSV function, and append each one to a list called data frames. Then comes the important part, that is pd.concat. This takes our entire list of data frames and stacks them into one combined data frame. We set ignore index is equal to true, so the row numbers reset cleanly instead of repeating. Finally, two CSV writes that merge data frame out to a brand new file called mergeoutput.csv, and index is equal to false. Make sure we don't write an extra unwanted index column into our output. So if you had, say, an HR file with employee ID, name, department, and salary, and a bunch of other CSV file with the same structure, the scripts will pull them all together in one clean file ready for next stage of analysis. For implementing this project, I have used VS Code, so in which I have created one project named data pipeline, in which 3 CSV files are there and one pipeline.py file is there for Python code. So you can write that code in the .py file. Student123.csv file will be having data and py file will be having your Python code for merging file. So you can run this file using Python 3 command, Python 3 pipeline.py, and you will get final output with merge files, and that output will get stored in merge.output file. So in this way you can implement your project. This data pipeline solution can be applied across multiple industries. In banking and finance, it helps consolidate transaction data from different branches. In healthcare, in e-commerce and retail, it merges sales and customer data to generate valuable insights. As a result, the system successfully reads multiple CSV files from a directory, combines all records into a single consistent data frame, and stores the merged dataset into a new output CSV file. This prepared dataset is now ready for cleaning, transformation, analysis, and visualization. Overall, this form the foundation of modern ETL extract, transform, and load workflows, enabling efficient and scalable data engineering solutions.